Got it. And we'll share screen. Share screen 1. And we'll get this going. All right. So lesson 6, we're talking machine learning, which is essentially not quite a synonym for AI, but a branch of AI. I don't know. It's difficult to define this sort of stuff for new tech, but we'll start with watching the provided video, and then there are a couple of fun activities that we'll do together, but you'll also do, and then a check for understanding, which is the only deliverable for this lesson. But that also means like a 2-word answer isn't gonna do it. So let's go ahead for real. Like when I do mean screens off and laptops closed, that's like the thing that I mean, the words when I say them. All right, so here we go. Listen, I think the audio's good.
My name is Alec Flores, and I'm a product manager at Alexa. My name is Dr. Chelsea Hout. I work at the Allen Institute for Artificial Intelligence, and I work on an AI-powered academic search engine. All around you, computers are making decisions, and those decisions affect your daily life. When you do an internet search or scroll through your newsfeed, computers decide what you see. Computers can already recognize your face and understand your voice, and soon will be driving cars and detecting diseases even better than humans have. So how is any of this possible?
You may have heard about something called AI, or artificial intelligence. True artificial intelligence is decades away. There's a type of AI called machine learning that is here today. It's a type of AI you probably interact with every day without even knowing it. And it has the opportunity to help us tackle some of the world's biggest challenges.
Machine learning is how computers recognize patterns and make decisions without being explicitly programmed. What's so exciting is that it's a completely different way to program a computer than what we've ever done before. With machine learning, instead of programming the computer step by step, you can program a computer to learn just like you learn, trial and error, and lots of practice.
Learning comes from experience, and that's true for machine learning too. In this case, experience means lots and lots of data. Machine learning can take in any kind of data, images, video, audio, or text, and begin to recognize patterns in that data. Once it learns to recognize patterns in the data, it can also learn to make predictions based on those patterns, like noticing the difference between an image of a car and an image of a bicycle.
AI and machine learning are playing a bigger and bigger role in society at large, and shaping all of our futures. That's why it's so important to learn how it works with some hands-on experience. You're about to get the chance to train your own machine learning model. Remember, AI is like any tool. First you get the knowledge, then you get the pattern.
Good stuff. All right. So you can go ahead and turn on your screens and computers and whatnot and make your way to bubble 2 of this lesson. The next 2 bubbles, 2, 3, 4, are variations on a pretty interesting AI widget. Lovely. Okay. Where you are given the task of teaching this computer, hypothetical, what is trash and what what belongs in a marine environment and what doesn't, And based on that, the computer should be able to learn. Okay, you guys can go ahead and do this. You don't have to wait for me, but so you're going to tell it which, that's just lovely, unnecessary sound effects. Is it supposed to be like a fish bubble, or like what is that sound? Sort of like if a fish was typing with bubbles. I don't know. You are going to tell it or instruct the machine what is a fish and what is not a fish. And based on that, it should be able to tell. Now, I don't know what it says about me, but my first instinct, 17 billion pounds of trash enter the ocean each year. So yeah, another slide some environmentalism in there. Why not? Trying to teach. Come on, give me a second. I don't know what it says about me. My first thought is, can I break this? Like not even just contextually, I assume it works if I do what it wants me to do. And feel free to do it that way, and feel free to do it over and over again just to see what happens. But it should let you, well, I don't know. It'd be interesting to see what it does when you are 80% of ocean pollution comes from land debris. So where does the other 20% come from? Boats? Planes? I don't know. I must be reading that wrong. And the cost of $13 billion per year is the cost to clean it up or the value of the pollution? Either way, I'm sure their intent was positive. If you make wrong choices, AI will repeat your mistakes. Okay, I think it is the next bubble. How many, did it say how many we need? Yeah, it actually is pretty consistent where it's learning things, or it's replicating learning things that you might not be aware of, as far as the way, obviously it's getting some wrong because I put in bad information. The way that machine learning works is by picking out small details and trying to find consistent or inconsistencies with that. Like, does it have, how much of it is brown, or are the lines curvy, or, you know, it can't see anything. It only knows the values of the pixels. So there's that. Okay, so go ahead and play around with it. You have to refresh in order to get back to the first part. Will it even let you get back to the first part? Oh, I don't want to sit through this again. Let's just go ahead and mute that. That's not helping anybody. I guess the only way to like really test how this works would be to have some sort of consistent, I'm going to do everything intentionally wrong, or I'm going to say everything is a fish, or I'm going to say everything is not a fish, and see what happens. Just randomly back and forth isn't going to prove anything, at least from a, let's see if we can break this standpoint. Either way, you'll see that it is pretty consistent with following your instructions, the training instructions. So you can, yeah, play around with that and then keep going. can train more. Wow, it's a lot of instructions that they're forcing me to. Oh, I guess I didn't count anything as not a fish. All right, I guess I really am breaking it. All right, either way. I do wonder if the training is continuing here. Either fish or not a fish. Jeez, really? Fish training, decide whether it belongs in the water. All right, so the point of this is we're training what is a fish, but then we're forgetting things that aren't fish that should still be there. And that's sort of the point of this activity, is about AI only learns what we teach it. Let's see if we can get to the next thing, and then we'll watch the last video together. All right, let's do it right. Let's belongs in the water. Yes, yes. We're assuming none of these are invasive species. No. Yep. No, yes, 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 sure, no, yes, yes, no. Debatable whether or not the environmentalist side is distracting from the point. Obviously, the intention is good. Doesn't belong. I don't know. Food waste is probably useful to animals as it breaks down. Debatable on that used chicken leg. Sure, sure. That feels like enough things. Well, let me skip. Okay. Oh no. I guess I didn't train it enough because it thought, yeah, it thinks those things belong, because I never came across a can and told it cans are no good. It thinks the can is good. All right, there we go. More of the point. Yeah, not good. All right, so is this the next bubble? Yeah. All right, so let's do screens off again. Let's watch this together so I know you're paying attention. Go ahead, like for real, screens off. Even if you're doing work for another class, turn your screen off. Like what's the plan, folks?
Machine learning is only as good as the training data. So it's super important to use high quality data and lots of it. But if data is so important, it's worth asking, where does training data come from? Often, computers are collecting training data from people like you and me without any effort on our part. A video streaming service might keep track of what you watch, then it can recognize patterns in that data to recommend what you might want to watch next. Other times, you're directly asked to help, like when a website asks you to spot street signs and photos. You're providing training data to help a machine learn.
Okay, so this is one of those hidden in plain sight situations. Those of you listening may take away some something from this other than Clash of Clans. Fantastic. So I'm sure you've experienced the captchas of, are there any boats in this picture? And the old fashioned type of captcha where like, what does this text say? Yes, its initial purpose was to determine whether you or not you are a robot, which is an interesting challenge to begin with. Just as an aside, how do you design a situation where a robot can detect whether or not the person or thing they're interacting with is a robot? That's like a whole mind-blowing concept. Anyway, the old written ones were designed to teach computers how to read handwriting. Yes, it had the purpose of detecting, bots from making email accounts or whatever it was used for. But the idea of crowdsourcing this problem and double multitasking it to get double use out of it for training computers while it was detecting bots is absolutely genius to solve both those problems. Now, you and I and anybody else creating accounts in places are helping to train self-driving cars by saying, what are the things in this picture that are buses or bicycles or pedestrians? With enough people all doing this, also pretending like it's a CAPTCHA and making people think it matters, even though they already know you're not a robot from other ways. They are still using you to crowdsource 30 seconds at a time this problem of teaching computers how to navigate the world. It's just genius hidden in plain sight how they're solving that problem. But either way, the key is tons and tons of data provided by lots and lots of people who think it matters. That's important.
Succeed, maybe even one day drop. Medical researchers can use medical images as training data to teach computers how to recognize and diagnose diseases. Machine learning needs hundreds and thousands of images and training direction from a doctor who knows what to look for before it can correctly identify disease. Even with thousands of examples, there can be problems with the computer's predictions. If X-ray data is only collected from men, then the computer's predictions may only work for them. It may not recognize diseases when it has to diagnose the X-ray of a woman. This blind spot in the training data creates something called bias. Bias data favors some things and deprioritizes or excludes others. Depending on how training data is collected, who is doing the collecting, and how the data is fed into the computer, there is a chance that human bias is included in the data. By learning from biased data, the computer may make biased predictions. This can happen whether the people training the computer are aware of it or not. So when you are looking at training data, ask yourself two questions. Is this enough data to accurately train a computer? And does this data represent all possible scenarios and users without bias? This is where you as the human trainer can play a crucial role. It's up to you to give your machine unbiased data. That means collecting tons of examples, often from lots of different sources. Remember, when you pick and choose data from machine learning, you're actually programming the algorithm using training data instead of code. The data is the code. The better the data you provide, the better the computer will learn.
Outstanding. All right, so moving forward, go ahead and let's do screens on and laptops and whatnot to bubble 6. And you guys can continue on with this. And then see if you come up with any interesting results. And like I said, the deliverable for today is the check for understanding at the end. Let's see what that looks like. And let's just go over this down. I'll let you guys cruise along through bubble 6 and 7 at your own pace. Bubble 8 is the checks you're for understanding reflection. Okay, think about examples of machine learning learned you may have encountered in the past, such as what websites recommend, and are the recommendations ever wrong or unfair? Give an example, explain how this could be addressed. Okay, 2 parts. Are they ever wrong or unfair? And give an example how this could be addressed. This second part question clearly implies that the first one, the result or your answer to the first one is yes. You're like, no, they're never wrong or unfair. How could this be addressed? Why does it need to be addressed? I said no to the first part. Okay. Don't fight the process. Just go ahead and give me a good answer. And when you're done with that, that is the coursework for today. Many of you are missing easy, low-hanging fruit of points from the last couple weeks, all the data, Google Doc assignments. Make sure that you get those in. If you turn them in, I will see them. You don't need to send me an email about Google Doc assignments.